Now that we have a virtual router connected to the VMBR 100 network and serving DHCP configurations on this network, we can consider installing the Devlab BVE. In this episode, after installing the BVE, we will improve our automation scripts and lay the ground for continuous integration and infrastructure as code, which will come later in the series. Installing the Devlab BVE inside my main BVE is called nested virtualization. That means installing a hypervisor inside a virtual machine instead of real hardware. Proxmox supports nested virtualization, and they have a guide for that on their website. The guide includes instructions for configuring the Proxmox Linux kernel to support hardware-assisted nested virtualization. Without hardware assistance, nested virtualization would be so slow and almost useless. The guide is very easy to follow and contains examples for Intel CPU. I have a Ryzen CPU by AMD, and I can verify that hardware-assisted virtualization is enabled with this command. To use hardware-assisted virtualization in our guest VMs, we need to configure our VMs to use the host CPU. We will see how to do that while installing the Devlab BVE. I tried automating the BVE install without success. I followed Proxmox instructions in their guide to install BVE over Debian, and started with a Debian cloud image that I can download with Ansible, but found that the image is not ready for resizing using Proxmox tools. I wrote a script to fix that and to enable SSH by default in the image, but struggled with the configurations of the BVE packages, which could not run unattended and required user input, which prevents automating the process with Ansible. Here is my script for unattended install of Proxmox. We check the image. We see that the image is only 2 GB. So we resize the image. And after resizing the image, we see that we have a resized image, but the root partition is still not resized. We still have 2 GB only in the root partition. So we need to solve that. How we solve that is we use QEMU MBD, which enables us to mount the image using the QEMU virtualization platform. We mount the image and we try to extend the partition, the root partition. So we extend the root partition to take 100% of the space. Then we extend the file system. The image is resized, and now we see that the root partition has 8 GB, which is what we expect, what we want. So now we want to install the requirements for Proxmox in that image. We download the signing key and we add the repository inside the image with virt customize. All this works, and then we solve the problem with the SSH not starting because Debian does not have default SSH keys, which is normal. Then we inject our SSH key and we try to install the BVE kernel. We fail when we try to configure grub PC. This image works in Proxmox. If you attach this image to a virtual machine and boot it, it will boot using the new kernel. But unfortunately, I decided to stop here and continue with manual installation of PVE because I could not trust the image that has these errors to continue for the future. I want to create a devlab inside the main devlab. So I start by creating a VM. I'll give it ID 229 and call it devlab. I want it to start at boot. Then I have already downloaded the Proxmox VE image, so I'm attaching it. The graphics card is as usual Spice. 32 GB is fine, but I'll give it 64. We also add disk card and SSD emulation. Now in the CPU, the most important thing is to choose the host CPU. This will enable hardware-assisted virtualization. I'll give it 6 cores now. I have a lot of RAM here, so I'll give it 20 GB. Now this will be on VMBR 100. And the MAC address, we give it 12. Because as we said previously, this is how we format our MAC addresses, and 02 and 29. So now I know that the router will give this image the appropriate IP for its VM ID, which is 229. And let's start the image and see what happens. I want to put all the space in the root partition. So I don't want the local LVM partition that Proxmox creates by default. I am in Sweden and I use a Swedish keyboard. The router is working and gave us the correct IPs. So Proxmox takes that by default. And that's why I installed the router before Proxmox. Our Devlab BVE was installed, and we can confirm that by going into a VM that is connected to VMBR 100, so it has an IP on this network. So we now have a new PVE. This should be the Devlab PVE, but since this is nested inside a nested installation, I will keep it for the time being for testing. And later on, I will remove it and I will use another PVE running on my main Devlab as the Devlab PVE for this series. So now if we want to create containers on this Devlab PVE, we need to start by first downloading the container templates. And if I look at the templates here, I see that I have the Debian 12 template enabled by default, available by default. So let me download it. And with the Debian template downloaded, we can now start creating LXC containers on this Devlab BVE. I created a new variable file for the new Devlab BVE that we have. There are only two differences between the Devlab, this file, the new file, and the old BVE. The differences are in the IP and in the node name. The IP here is 229 and is on the 100 network, and the node name is Devlab, which is what we have in here. I created also a playbook to install development environment. This is a generic development environment. And in this development environment, we use the new variable file for the new PVE. And we purge the container if it exists and recreate it again. These are the two roles that we created earlier. I added a new role that we will see later on, and I also have another variable file to create another development environment, and these two will run on VMBR 0. And let's see what happens when we try to create the first one. And then the base role is running, and we will see what the base role does later on. So we created the first one. Let's try with the second one. Now let's have a look at the new role that we created. The base role is what I want to run on every new container, or on every container, not just new, that I have in my Devlab, on all the development containers that are based on Debian. First, we do a full upgrade on all the containers. Then we install a few packages that I'll show you the packages in the variables file. Then we remove some packages, and I'll show you the packages that we remove later on. Then we create a dev user. That would be the user that I log in to the container, and we enable SSH for this user, and we also enable sudo for this user, and we enable remote access from the development machine. Then we remove expired public keys if you want to change some public keys. I do the same for the Ansible user. I create an Ansible user, and the Ansible user has the SSH keys that I know for the Ansible controller, and I enable sudo for the Ansible user so that I can use Ansible become later on. I have some sites that I want to block from the container, from every container, and I add default aliases in the container. This is the Vault template, and I added dev username and dev user password, Ansible username and Ansible user password. The passwords for these has to be hashed, and there is a documentation for how to generate the hashed passwords. And in this example, the hashed password is password. Let's look also at the variable file. Oh, the variables files here, I don't have a variable file for the base role. I keep everything in defaults because these are the default things that I want to have for every thing that I want to install. So I have apt install, sudo curl git zip locals all rsync and gnu bg and python 3 openssl. I remove postfix from the container because I don't want a mail server running on every development container I have. This is the public SSH key for this VM, so that I can access this container from the VM. Now, these are some sites that I want to block, and I block these by default because if I run VS Code will send telemetry to these, and I have thousands of requests to these on my byhole on the main network. And I have aliases, for example, I like using LL, which is ls-alf. I have also a playbook to run this role on the base hosts. The base host is a collection. It has children, and the children are devenv1 and devenv2, which are what you see here. When I call the role, I don't need any variables here because this role does not require, the base role does not require any variable other than access to the vault, which is required for the usernames and passwords of the Ansible user and the dev user. So let's try running this role on both hosts now. Ansible playbook -i inventory, and I run the base role. Those packages are installed. Everything is installed, and we succeeded. We did not have any failure. The idea of creating this base role is first to enable default configuration, and later on, if I change anything in this file, for example, if I want to add a new package to all my containers, I can configure my continuous integration system to detect the change in this file and to run this playbook again. And we will see how that is done after a few episodes. Let's test our new role to see if it works. So if I open VS Codium on the machine that is connected to the VMBR0 role, I see that I have added the development environment to my shell configuration, which is recognized by the shell remote shell extension. And now I can open this host, opening remote. So you see I have logged into the host immediately without a password. And that means I have my public key in the authorized keys of the user on this machine. And I can confirm that by opening a folder, the SSH folder, for example. And here we see that I have the SSH key for this host. We created an SSH key for the host, and on the authorized keys, I have my key authorized here. And if I open the terminal and try LL, I see LL command not found, which means the alias is not working. Let's see with a normal login session. So if I open a normal login session and if I SSH to dev-n1 and do LL here, I see that LL works here, which means there is a bug either in my role, in the role I created, or in VS Codium. If we look at the way we define, we add the alias, we see that we added a script in the profile.d folder, which is supposed to be executed on every new login session. Apparently, the shell session is a normal login session, but VS Codium sessions are not normal login sessions. So I need to investigate that and try to find a solution later. Now that we have an operational Devlab, next we need to set up Git and continuous integration for our Devlab. And for that, I plan to install GitLab and Jenkins with GitLab runners and Jenkins runners inside the Devlab so that we can do continuous integration and infrastructure as code. I still have other plans for the future. For example, we will do shared folders across the dev containers. We will start creating specific containers, for example, PHP containers, Python containers, Python development containers. All that is coming in this season of the Devlab. Please subscribe so that you don't miss the upcoming episodes, and talk to you later.